Okay, so in this example, we have this diagram that shows an object A moving to over here to B following this pattern. So we want to see what the work done by the normal force is. So the normal force is perpendicular to the displacement. So perpendicular to the displacement. So since it's perpendicular to the displacement, the work done by N is 0 because the normal force doesn't affect the change in the kinetic energy. So it's 0. Now we also want to find the work done by the gravitational force, or F equals negative mg in the j direction. So in order to find this out, we have to use this formula. So we know that the net work is equal to the work of the normal force plus the work of mg. So as we saw before, the work of the normal force is 0 plus the work of mg, which we know is mg y1 minus y2. So the work of the gravitational force, or F equals negative mg in the j direction, is mg y1 minus y2. Now the next thing we want to see is what the speed is at point B. So what is the speed of the object when it's going from object A to B? So we want to start by using this equation. The work is equal to the displacement, or the change in the kinetic energy. So we know that the net work in this situation is mg y1 minus y2. And we know that the change in the kinetic energy is 1/2 mv final squared minus 1/2 mv initial squared. So now we can solve this. So let's say that y2 is 0. And y2 is 0 because that's when it stops. So then we would take off this y2. So we would just have mg y1 equals the change in the kinetic energy. Now let's say that v initial is 0. So if v initial is 0, then this goes away. So we have mg y1 equals 1/2 mv final squared. So we take off the m's, and when we solve, we'll have that the velocity final is 2gy1, the square root of 2gy1, and that is the velocity at B.